Okay, from lesson number 1, question number 9, continuing with the theme of linear combinations. Um, they tell us A and B are not collinear, so that means it is possible to move across the plane. So they want us to know or figure out what the values of x and y, and we've got to be careful because x and y are scalars this time. All right, so they're just scalars, and we want to make it find x and y to make that work. So what the question is saying, if we take 2 times u, then we subtract the v vector, we're going to end up with a w vector. So I am going to take what the u vector is and replace it. V vector. This is where you got to really watch your vector signs because you got to remember what is a vector and what isn't in this case. V is 2y a vector plus 3y b vector. That's going to equal 4a minus 2b. All right, so first thing I'm going to do is distributive law here. So 2xa plus 4yb plus, distributing that negative in. Okay, this is where 90% of mistakes are made if you tried the question. It's that sign, 2ya minus 3yb equals 4a minus 2b. And there's a couple of ways at this point which you can do it. I'm actually going to group my a terms together. All right. So I'm going to take those a terms, I'm going to take them together, and I'm going to factor out the a. So I'm going to do 2 things at once. I'm going to group them together, and I'm going to factor out the a. That leaves me with 2x plus 2y. So I common factored out the a vector. And remember, with vectors, they follow all our rules for algebra. So we can factor, distribute, etc., etc. So you can do whatever you can do with an algebraic equation. You can do the same with vectors when you're rearranging. So now I take my b vectors, and I'm going to do the same thing. I'm going to common factor out a b vector, which would leave me with 4y minus 3y, and that's equal to 4a minus 2b. So for the a vector, I know in the end, the a vector, the coefficient has to be a 4. So that means that here's my a vector. This is going to have to equal 4. So from here, we can kind of jump out. I know that 2x plus 2y is going to have to equal 4. Divide everything by 2. I know x plus y has to equal 2. So can't take that any further, but I know that the b vector has to result in a negative 2. So the coefficient 4y minus 3y has to equal negative 2. 4y minus 3y, they're like terms. So right away, I can find that my y is negative 2, which allows me to finish up over here, and I get x equals 4. So therefore, to make that work, x has to be a 4, and y has to be a negative 2. So it's just playing different, it's the same game, just a little bit different rules here when we're rearranging equations and determining what's needed, but it ties back to that linear combinations and adding and subtracting vectors. If you have any questions, let me know, and I'll see if I can clear them up for you.